Hello everyone. Let's continue our topic equation of motion with uniform acceleration. Uniform acceleration means constant acceleration. So we know that from the basics of physics that acceleration is the result of force. So we have force is equal to ma. So when force is constant, mass is constant, and acceleration is also constant. So when constant acceleration is there, the velocity will change at a constant rate. For example, if I'm saying acceleration is 1 meter per second square, so that means 1 meter per second per second. What you call this? 1 meter per second means every second the velocity will change by 1 meter per second. For example, t is equal to 0, velocity is 1 meter per second. So after 1 second, the velocity will change by 1, and change is positive. So it will become 1 plus 1. So that is 2 meter per second. Velocity will be 2 meter per second. And at t is equal to 2 second, velocity will be, now from 1 to 2 second, the velocity will again change by 1 meter per second. So at 1 second, velocity is 2 meter per second. So at 2 second, velocity will be 2 plus 1, that is 3 meter per second. So this is how acceleration works. It changes velocity. It can increase velocity, it can decrease velocity. When it will increase velocity and when it will decrease velocity, we have discussed this already in the previous discussion. When acceleration and velocity are in same direction, so velocity increases. When acceleration and velocity are in opposite direction, for example, velocity is rightward, acceleration is leftward, so in this case velocity decreases. So we derived equation of motion, that is v is equal to u plus at when the acceleration is constant. Here v is final velocity. We have to take care of sign. If particle is going right side, then we have to take it as positive. Particle is going left side, then we have to take it as negative. So v can be plus or minus depending on the particle is going right side or left side. Similarly, initial velocity, that is also, if particle is going right side, so u will be plus. If particle is going left side, u will be negative. Similarly, for acceleration, a is the acceleration, t is the time interval or time duration. It can be 0 to 1, 1 to 2, or 0 to 2, or 3 to 7, or 0 to 6. From initial time instant to final time instant, you have to take difference. So basically time interval is delta t, t final minus t initial. So we have done some questions also in the previous lecture. Now we are going into next equation of motion, which will give us displacement. So we know that v is equal to dx by dt. So dx is equal to v dt, and we know that v is equal to u plus at. So we have dx is equal to u plus at into dt. U plus at bracket into dt. So this will be dx is equal to u dt plus at dt. So this is a small displacement. So a small displacement is the addition of u into dt plus at into dt. So what is the total displacement? You have to integrate. So total displacement will be integration of dx, which is integration of u dt plus integration of at dt. Now we are assuming that the initial time is 0, so final time is t. Suppose the time changes from 0 second to 2 second, so we will write 0 to 2. If time changes from 1 second to 2 second, so we will write 1 to 2. So here we are assuming 0 to t, and initial position is x1, final position is x2. So left hand side we will get delta x, which is equal to x2 minus x1, or we can say x with limits x1 to x2, lower limit x1, upper limit x2. So that will be same as x2 minus x1, and on right hand side we will get integration of u dt. Now here u is a fixed quantity. It is initial velocity, so it is fixed, because initial velocity is the velocity at t is equal to 0. Whatever is it at t is equal to 0, always it is same. It is the final velocity which is changing with time. So u is same, u is initial velocity, v is changing with time. So we can take u outside of integration. So this will become u integration of dt from 0 to t, plus acceleration is also constant. We can take it out of integration. Now let's solve this. So we have delta x, which is s. This is denoted for displacement. So displacement is equal to u integration of dt, which is ut from limits 0 to t, plus a t dt integration will be t square by 2 limits 0 to t. So we have s is equal to, now this will be u into t minus 0 plus a by 2 into t square minus 0 square. So this will become s is equal to ut plus half at square. So this is the derivation of second equation of motion using integration. Second equation of motion using integration. We can derive this using area under graph also, because we know that displacement is equal to area under velocity time graph. So let's derive this equation using area under graph. So we will draw velocity time graph to derive s is equal to ut plus half at square. So let's consider vertical axis is denoted by velocity in meter per second, and horizontal axis is time axis in seconds. So according to the information, the initial velocity is u. So suppose this is the initial velocity u, it is positive. I am assuming it is positive. Now the acceleration is uniform and positive. So here I am writing what I am assuming. Let u is positive and acceleration positive. Acceleration is also positive. So initial velocity is positive, means the particle is going rightward, and acceleration is also rightward. So the velocity will increase linearly. Velocity increase linearly. Why? Because acceleration is constant. it is understood in this topic that acceleration is constant, it is uniform acceleration. So we will have the graph like this. It will be a straight line graph. This is a straight line graph. The velocity is increasing linearly, so that after time t, that means from 0 second to t seconds, the velocity will change from u to v. Now we will find the area under this graph, this complete area, which is the sum of triangular region and rectangular region. So this is the total area under the graph. We have to calculate this, and that will give you the total displacement. So the area of this triangular region will be half into base into height. So the base is t and the height of this triangle is v minus u. So this area will be half into base into height, then plus this area is for triangular region. Now we have a rectangular region. Rectangular region, the height is u and the base is t. So length into breadth, so this will become u into t. So this is the total displacement. So we will get S is equal to, I'm taking t common, so this will be v minus u by 2 plus u. So S is equal to t into v by 2 minus u by 2 plus u. So S is equal to t into v by 2 minus u by 2 plus u will be u by 2. So S is equal to v plus u into t by 2. So this is the formula for displacement, which is v plus u bracket into t by 2. And we know that v is equal to u plus at. V is equal to u plus at. We will substitute v is equal to u plus at here. So we'll get S is equal to u plus at plus u into t by 2. So we have S is equal to 2u plus at into t by 2. So we have S is equal to, now multiply t by 2 with 2u and at. So this will be 2u into t by 2 plus at into t by 2. So S is equal to ut plus 1 by 2 times at square. So this is our second equation of motion. Second equation of motion. So it can be derived using integration, it can be derived using area under the graph. So now we have two equations of motion. V is equal to u plus at and S is equal to ut plus half at square. And if you have noticed, we have one more equation. S is equal to v plus u t by 2. I will come to this equation once again later. So let's write all the equations till now what we have learned. So I am writing first equation as v is equal to u plus at, and second equation as S is equal to ut plus half at square. And third equation we will get when we will substitute the time from first equation in second. So basically I'm doing s is equal to u into t, which is v minus u by a, plus a by 2 into t square, which is v minus u by a whole square. So we'll get this is uv minus u square by a plus v square plus u square minus 2uv by 2a. Take 1 by a common, so this is uv minus u square plus v square plus u square minus 2uv by 2. If we simplify this, we'll get 1 by a into 2uv minus 2u square plus v square plus u square minus 2uv. So 2uv minus 2uv cancel. So 1 by a is equal to v square minus u square by 2. So 2as is equal to v square minus u square. So v square minus u square is equal to 2as. This is our third equation of motion, and fourth equation of motion also there, which we have derived during the discussion of area under the graph, which is s is equal to v plus u into t by 2. This is also important equation, so I am calling it as fourth equation of motion. S is equal to v plus u into t by 2. And fifth equation of motion, we will see when you put u is equal to v minus at in second equation. So in second equation, s is equal to ut plus half at square. We will put we know that v is equal to u plus at, so u will be equal to v minus at. Now put it here. So s is equal to v minus at into t plus a by 2 into t square. So s is equal to vt minus at square plus a by 2 into t square. So s is equal to vt minus half a t square. So this is our another equation of motion. We can call it fifth equation of motion. S is equal to vt minus half a t square. So these are the 5 equations of motion. If you notice, these equations of motion are relating the quantities u, v, a, t and s. These 5 quantities, these 5 equations of motion are relating. And one more thing that you will notice in these 5 equations of motion is, in the first equation we don't have s, in the second equation of motion we don't have v, in third equation of motion we don't have time, in fourth equation of motion we don't have acceleration, in fifth equation of motion we don't have u. So at a time, in one equation we have 4 quantities related. So they relate 4 quantities in one equation. 4 quantities in one equation. So when we solve the questions related to equations of motion, we have to remember these points. If in a question u is given, a is given, t is given, then we can find v. If in a question v is given, u is given, t is given, time duration is given, then we can find s. If v, u, s given, we can find a. If v, a, t is given, we can find s. So let's take some questions related to these equations. We will use these equations to solve those problems. So let's start with first question. Question number 1. A car changes velocity from 2 meter per second to 5 meter per second in 3 seconds. Find displacement and find acceleration. So how to find displacement directly? So we have equation of motion, s is equal to v plus u into t by 2. So we will write what is given first, write down what is given first, changes its velocity, so from 2 to 5. So acceleration is constant, it is understood that uniform acceleration is there. Uniform acceleration means constant acceleration. We don't know how much is the acceleration, but these type of questions, the acceleration is uniform. Sometimes it is mentioned in the question, sometimes it is not mentioned, so you have to assume it is uniform. So we will use s is equal to u plus v into t by 2. Now time is given 3 and u and v given, so 2 plus 5 into 3 by 2, so that will be 7 into 3 by 2, so that is 21 by 2. So 10.5 meter, 10.5 meter, this is the displacement. How to find acceleration directly? So we will use v is equal to u plus at. So we have v minus u is equal to at. So a is equal to v minus u by t. So v is 5, u is 2, time is 3. So acceleration is 3 by 3. So acceleration is 1 meter per second square. Acceleration is 1 meter per second square. Let's take second question. After covering displacement of 5 meter, velocity is doubled. Velocity is doubled. And time taken is 4 seconds. Now I will ask 3 questions here. Find A, find U, find V. Find V. So for this question, again we will write down what is given. So we can draw a diagram also. The path followed by the particle, it is a straight line. All these questions are related to motion along one dimension, that is straight line motion. So initial velocity you can assume x, or if you want to assume some other symbol, let's take initial velocity is u. So final velocity will be 2u. This is initial velocity and final velocity is 2u, and the displacement covered from A to B is given in the question, it is 5 meter. So displacement is equal to 5 meter. U and V are not given, but it is mentioned that the velocity is doubled. Time is also given. Time is equal to 4 seconds. Can we find U? Can we find V? Let's find out. So again we will use S is equal to V plus U into T by 2. So S is 5, V is 2U, U is U, time is 4. So this is 4 by 2. So we'll solve this. So 5 is equal to 3U into 2. So 5 is equal to 6U. So U is equal to 5 by 6 meter per second. So V will be equal to 10 by 6 meter per second. We got the value of U and V. And acceleration, for acceleration we can use V is equal to U plus at. So acceleration is equal to v minus u by t. So acceleration is equal to v minus u by t, which is 2u minus u by t, that is equal to u by t, and u we got 5 by 6, and time is 4, so this will be equal to 5 by 24 meter per second square. This is the acceleration. Let's take one more example. Now, in the previous two examples, we have discussed rightward motion. As you observe, u, v, a, s, these all vector quantities are positive. So the particle is traveling along rightward direction. Now let's solve some questions in which the particle is moving left, or sometimes it is going left, and for remaining time it is going right. So that is combination of leftward motion and rightward motion. In a question it is given that initial velocity is 3 meter per second left, but acceleration is 2 meter per second square right. Now what is the situation here? Acceleration is opposite to velocity. So when acceleration is opposite to velocity, velocity decreases. So suppose this is the straight line along which the particle is moving. So initially the car is at A and the velocity is 3 meter per second, but the acceleration of the car is right side. It is 2 meter per second square. So velocity will decrease. Velocity will decrease. There is a retardation. Velocity is decreasing. After some time, the velocity will become 0. Let us suppose that point is B when the velocity becomes 0. Now the car comes to rest. But we assume that acceleration is continuously working. In physics, there are some cases when acceleration is continuous. I will give one example of that. So let's assume this object I am holding in this hand. If you throw this object vertically like this, if you observe, I am throwing this object vertically upward. So the initial velocity is upward, but the acceleration is downward. That is acceleration due to gravity. So if you observe carefully, the velocity is decreasing. At topmost point, velocity becomes 0. Topmost point velocity 0. But it is not at rest here. Can I say it is rest? It is at rest, but permanently at rest? No. Immediately after that, it is coming down. The velocity is becoming 0 at the topmost point. After that, it is reversed. The direction is reversed. So before it is going upward, reaching the topmost point, now it is coming downwards. So what happens? What is this? What you call this? It is known as U-turn. So when acceleration is continuously acting, but initial velocity is opposite to acceleration, the particle will take U-turn. So in this situation, acceleration is rightward, initial velocity is leftward. So the particle will go left side until it comes to rest. Then it will not be at rest permanently, it will go right side. Now it will go right side. So the motion will be like this. It is going left side, then it is going right side. Now, so I will ask some questions. So first question, find distance covered in 4 seconds. So let's solve this question. So first you find out after what time velocity is 0, because it is a U-turn type questions. So in U-turn type questions, you have to calculate leftward displacement and rightward displacement separately. And leftward displacement will be negative, rightward displacement will be positive. So take magnitude of both, add, you get distance. So suppose this is S1 and S2. So magnitude of S1 plus magnitude of S2 will be the distance. So how to find distance? Here we will see how much time it is taking for velocity to become 0. So let's find out. Time for velocity becoming 0. So for that we will use v is equal to u plus at. Put v equal to 0, u is equal to minus 3 because it is 3 meter per second left, acceleration is 2 and time is t. So 3 is equal to 2t, so 1.5 second, time is equal to 1.5 second. So for this situation, leftward direction, for leftward direction it is going for 1.5 second, but in the question they are asking what is the distance in 4 seconds. So 1.5 second it has moved or spent while going left side. Now how much is remaining time? Remaining time will be 4 minus 1.5, that is 2.5. 4 minus 1.5, that is 2.5. So for 1.5 second the car is continuing its motion left side. For next 2.5 second the car is going right side. So S1 is negative, S2 is positive. How to find S1 and S2? So for S1, now we got U value is minus 3, A value is plus 2. Now time also we got, it is 1.5 seconds, and we also know V also we know it is 0. So we can use V square minus U square is equal to 2AS. We can also use S is equal to UT plus half AT square. So I'm using V square minus U square is equal to 2AS1. So 0 square minus 3 whole square is equal to 2A into S1. So minus of 9 is equal to 4S1. So S1 is equal to minus 9 by 4, that is minus 2.25 meter. First displacement is minus 2.25 meter. Now how to find second displacement? For second displacement u will be 0. Now starting from B, the velocity is a 0 and the particle is going right side. So acceleration is still same, which is 2, u is 0, and time we know it is 2.5 seconds. So rightward motion is covered in 2.5 seconds. We are observing it for 2.5 seconds. So now how to find displacement S2? So we will use S is equal to ut plus half AT square. So this will become S2 is equal to u into t plus half A, which is 2, time is 2.5. So we have S is equal to this 2 to cancel, then 2.5 square, which is 6.25 meter. So S2 we got 6.25 meter. So that shows leftward displacement is 2.25 meter and rightward displacement is 6.25 meter. So total distance is 2.25 plus 6.25. So this will become 8.5 meter. Total distance is 8.5 meter. So next question. Next question is little tricky. Like for example, the values are not given, acceleration value is not given, uh, but still we can find the answer. So let's solve the question. Let's write the question first. So the question says car changes its velocity from v1 meter per second to v2 meter per second. We assume that both are positive. Both positive means the particle is going rightward. It is assumed in the question itself. While covering displacement from point A to point B along straight line, along straight line, along straight line. So what is the situation in this question? There is a straight line. This is a straight line. The question is mentioning 2 points A and B. The question is also mentioning at A the velocity is v1, at B velocity is v2. But what is the question in this situation? You have to find velocity at midpoint. Find velocity at midpoint. So yesterday we discussed similar question which was based on time, but this question is based on displacement. So A to B displacement is S and A to C displacement, which is the midpoint, will be S by 2. So this is what you can observe. And acceleration is uniform. It is again, it is understood, sometimes it will be mentioned in the question itself. The acceleration is uniform, acceleration is constant, so that we can use equations of motion. Equations of motion are used only when acceleration is uniform or constant. So along a straight line. So one time we will use v square minus u square is equal to 2as for A to B. A to B, so we will get v2 square minus v1 square is equal to 2as. Now next time you use the same equation, v square minus u square is equal to 2as for A to C. For A to C, now the velocity at C, let us suppose it is v3. So v3 square minus v1 square is equal to 2as by 2. Now divide these two equations. So this is first equation, this is second equation. Dividing, we'll get v2 square minus v1 square by v3 square minus v1 square is equal to 2as divided by 2as by 2, so that is equal to 2. This 2as and 2as will get cancelled. So we have V2 square minus V1 square is equal to 2V3 square minus 2V1 square. So V2 square minus V1 square plus 2V1 square is equal to 2V3 square. So we have V2 square plus V1 square is equal to 2V3 square. So we are getting V3 square as V1 square plus V2 square by 2. Then we have V3 is equal to square root of V1 square plus V2 square by 2. This is also known as midpoint formula. Midpoint formula. So these questions are using equations of motion. Let's move on to the next concept. Again, it is based on uniform acceleration. Sometimes we observe the car is going with constant velocity. Sometimes we observe the velocity of the car is increasing. And sometimes we observe that the velocity of car is decreasing. So let's do one question in which there is acceleration, retardation, uniform motion. So first let's do the motion in which first part is acceleration and second part is uniform motion. So directly I am drawing the route or the path followed by the car. A to B, the car is accelerating. So acceleration is there. Suppose the acceleration is A and B to C, it is uniform motion. So what is the initial velocity? Initial velocity at A, you can assume 0, you can assume some value like u. So I am assuming it to be 0. So car start from rest. Car start from rest. So over here the velocity of the car is 0. It is rest. Now acceleration is A. So for t1 seconds the car is going from A to B. So at B we will find what is the acceleration. So at B we will find what is the velocity. Let's call it V1. And B to C, the car will continue its motion with constant velocity. And time taken is T2. B to C time taken is T2. So the velocity at C is also V1. Let's find what is the total displacement. So total displacement will be S1 plus S2. How to find S1? We will use S is equal to ut plus half at square. So S1 will be ut plus half at square. When u is 0, S1 will be half a t square. So S1 is equal to half a t1 square. This is S1. For S2, the velocity is constant. So acceleration is 0. For S2, acceleration is 0. So we will use S is equal to ut and the velocity, initial velocity is V1. It is continuously V1. So we will use S is equal to ut. So S will be equal to V1 into T2. How to find V1? For V1, we will use V is equal to U plus At from A to B. For calculating V1, I'm using V is equal to U plus AT from A to B. So we will get V1 is equal to 0 plus AT1. So V1 is equal to AT1. Now we will put here in S2. So S2 is equal to AT1 into T2. So S2 is equal to AT1 T2. We can use this as short trick also. So total distance or total displacement both are equal here. Total displacement is equal to S1 plus S2. So that is equal to half A T1 square plus A T1 T2.